Lesson 2.2 is the graph of a function and analyzing graphs of functions. So here we have a graph of a function f of x, and it has a bunch of questions based on it. So using just the graph itself to answer these questions. So go ahead and pause the video and try this. For A, is f of x a function? Yes, if we look at the graph, it passes the vertical line test. There is no x value that has more than one y value. The only one that is a little bit iffy is right here at x equals 2, but because this one is an open circle, it means it's not included there, so it doesn't actually fail the vertical line test. It's only included up here, not at this open circle. Find the values of f of -1, f of 0, and f of 2. So at x equals -1, y is 1, so f of -1 is 1. At 0, f of 0 is 0. And at 2, f of 2 is 4. We want to do the included one, not the open circle. Is f of -4 positive or negative? F of -4 is down here, so therefore it would be negative value. For what values of x is f of x greater than 0? So at -2 to the left, everything is negative. At -2, it's equal to 0, and it doesn't want equal to. So it's positive or greater than 0 between -2, not included, to 0, but we don't want to include 0 because at 0 it equals 0, and we don't want or equal to, and then everything to the right, so then everything for x is greater than 0. What is the domain? This one, it doesn't really have an endpoint here. I'm just going to make the assumption that it's -6. There's a closed dot here, which means it stops at x equals -6. Everything, it jumps down, and then there's an arrow on this right side, which means it continues forever on to the right, so therefore x is greater than or equal to -6. What is the range of f? So I look to find the lowest y value, and it's again down here at this dot, which is -4. Everything's included all the way up to +4. So the range is -4 is less than or equal to y is less than or equal to 4. What are the x-intercepts? So where does it cross or touch the x-axis? At -2 and 0. And what are the y-intercepts? A function can only have at most 1, and it is at y equals 0. This one, they give us the function f of x equals x squared plus 2 over x plus 4, and they're asking us similar questions, but they gave us the function instead of the actual graph of it, but they're asking us questions about the graph. So go ahead and pause the video and try these. Part A says, is the point 1, 3/5 on the graph of f? I plugged in 1 and I got 3/5, so yes, that's the definition of being on the graph of the function. B says, if x equals 0, what is f of x? So I plugged in 0. I got 0 squared plus 2 over 0 plus 4, so 2 over 4 or 1/2. And then what is the actual point on the graph? 0, 1/2, so kind of two different ways to ask the question. The next part says, if f of x equals 1/2, what is x? So this is going the other way. They're giving us y, and we want to solve for x. A lot of us may have just said, oh, it's 0 because we got this in part B, but going the other direction, we can have more than one answer. So I set the function equal to 1/2, and I cross-multiplied. I got 2x squared plus 4 over equals x plus 4. I then, this is a quadratic, moved everything over, set one side equal to 0, and factored out an x. So I got x times 2x minus 1 equals 0. So therefore, x equals 0 or 1/2. So there's actually two answers to this one. When you do cross-multiply, you just have to be careful to make sure you take the domain into account. We'll talk more about solving rational functions a little bit later, but you just have to make sure that x equals -4 is not a solution. So our 2 points are 0, 1/2 and 1/2, 1/2. So kind of building off what I just said, D says, what is the domain of f? Well, this is a rational function. So like we talked about in the last section, I set my denominator not equal to 0, so therefore x cannot equal -4. E, what are the x-intercepts, if any? So a couple sections ago, we talked about x-intercepts. That's when your y-coordinate equals 0. So I set my function equal to 0. I multiplied both sides by x plus 4. So I got x squared plus 2 equals 0. So x squared equals -2, which is not possible in the real plane. So therefore, there are no x-intercepts. And what are your y-intercepts? So that is when your x-coordinate is equal to 0. We already did this in part B, so I didn't simplify it. It was equal to 1/2. But plug in 0 for x and simplify. So this section kind of took all of the pieces that we've talked about and put them together in the context of looking at a function's graph. So here we have the graph of two functions. We have f of x, which is this purple linear function, and g of x, which is this blue quadratic function. And we want to evaluate these operations on functions without writing any functions themselves. So we're just going to look at the graphs of them. So remember we talked about in last section that f plus g of x or of 4 or something means that we want f of 4 plus g of 4. So I'm going to look at my graphs and I'm going to evaluate these on my graph. So if I look at x equals 4 and I find f of 4, I see that f of 4 is equal to 1. And then if I find g of 4, I find that g of 4 is equal to negative 3. So 1 plus negative 3 is negative 2. So f plus g of 4 is negative 2. So go ahead and pause the video and try g minus f of 6 and f over g of 4. For 2, it says g minus f of 6, which is the same thing as g of 6 minus f of 6. So I went over here to where x equals 6, and g of 6 is 1, and f of 6 is 0, so 1 minus 0 is 1. And then f over g of 4 is f of 4 over g of 4, and we already evaluated f of 4 and g of 4 up here, so f of 4 is 1, and g of 4 is negative 3. Can't really simplify that any further, so negative 1/3. So we did this by looking at the graphs, not by writing a function, so being able to use multiple representations. So here we have a context problem. There are a lot of words in this context problem. Essentially what happens is a physicist has determined the perfect angle to shoot a free throw in basketball is 45 degrees. So if a shooter is shooting the ball from 45-degree angle and is 6 foot off the ground, then the height or the path of the ball can be modeled by the function h of x equals negative 44 over x squared over v squared plus x plus 6, where h is the height of the ball off the ground, x is the distance in front of the free throw line or the foul line, and v is the initial velocity of the ball. And then the last part says, suppose a player shoots a ball with an initial velocity of 28 feet per second. So part A says determine the height of the ball after it has traveled 8 feet in front of the foul line. So go ahead and pause the video and try that. So I plugged in 8 for x, and I plugged in 28 for my initial velocity v, and I got 10.408 feet. So if the ball is 8 feet in front of the free throw line, it will be 10.48 feet above the ground. So now go ahead and pause the video and determine the height of the ball after it has traveled 12 feet in front of the free throw line. So same idea on this one. I plugged in 12 for x this time. Initial velocity stayed at 28, and you end up with 9.918 feet. So go ahead and pause the video and try and sketch a little graph of the path of basketball. So I know the initial height is 6. Also, if I plug in 0 for x, these will go away and I'll be left with just 6. And then I kind of looked at the graphing calculator and saw that it's going to land somewhere between 20 and 25. So that is my sketch of a graph right there. So the last piece, the center of the hoop is 10 feet above the floor and 15 feet in front of the free throw line. So will the ball go through the hoop? Why or why not? And if not, what initial velocity should be used in order to make the ball go through the hoop? So go ahead and pause the video and try this one. So the first thing I did was I plugged in 15 for x, and I got that the height would be 8.372, which is less than 10 feet, so it would not go through the hoop, which you may have also just said from the fact that h of 12 was already less than 10, and looking at the graph, it's decreasing, so you may not have actually plugged it in, but it's the same idea. So then they said, okay, so then what would your velocity have to be in order for it to go through the hoop? So you still want x to be 15, and you still want it to equal 10 because you want it to be at least 10 feet above the ground. And so now I'm letting v be my unknown, and I subtracted the 15 and the 6 from both sides. I got negative 9,900 over v squared equals negative 11. I multiplied the v squared to both sides, got 9,900 equals 11 times v squared. I also multiplied the negative 1. Divided both sides by 11, v squared equals 900, took the square root. So your velocity should be at least 30 feet per second. So this has been the graphs of functions and tying together all the things we've done in our previous sections to functions and their graphs.